I'm going to start working on the practice number 1. Again, I'm only going to do the evens with you, and then your answer scramble has odds on it. So you'll go through the evens with me and then do the odds on your own. We will do these evens together. So we'll start with 2, 4, and 6. So for question number 2, it says factor out the GCF. You will have a question on your quiz and it will say factor out the GCF. It will be the same type of question. And so to factor out the GCF, what you're looking for is the biggest number. We'll start with the numbers. What's the biggest number that can divide into 28 that can also divide into 4? 4. So we're definitely going to divide out a 4. What was that, Elijah? And an X. So the biggest amount of X's that I can pull out of both of them would be just one of them. That GCF, that is called your GCF. We write it out in the front. It doesn't disappear. We write it in the front. And now we're going to write down what we have left. So I'm going to divide. What's 28 divided by 4?
7.
7. Very good. And then if I have X squared on top and X on the bottom, what that technically looks like, I'll do that off to the side so you can see it. If you have 2 X's on top and just 1 X on bottom, every time you have an X that matches up, then that reduces to 1. So you would just be left with 1 X on the top. So here it's just 1 X. What is 4 divided by 4? Hey, actually, it is the same thing over itself. Anything over itself is what? 1. So the 4's match up, the X's match up. So that's just a 1. It's not a nothing. It's a 1. Mm-hmm. So for GCF, that's it. For this one, I'm going to tell you that you're going to factor out the negative. I want you to factor out the negative because they both have a negative. I want the negative out in front. For this one, what's the GCF? It's easy. What's the biggest thing you can pull out of everything is a 2. So you just rewrite it with a 2 out in front, and then in parentheses, everything is just divided by 2. For these two, this is a difference of perfect squares. And so I made you guys pick up on day 1 or day 0. You should have picked up this like notes sheet. If you didn't get it, you can come and get it. But it's this factoring polynomial study guide. So if you didn't pick this up, you should pick it up. It's the very last pocket in the hanging file folders. So what's nice about these are this factoring worksheet, which I didn't create. I can't take credit for it. Somebody else did, and I found it on the internet. And I liked it, so I printed it for you. But what I do like about it is that it has a lot of examples. And so factoring GCF, like that's the first thing. Like it tells you the first row is factoring by GCF. So if you need some more examples with factoring with GCF, there are some more right there. And then it goes on to factoring by grouping, which we're going to do in a second. But it also goes down to difference of 2 squares. So there's a whole row. So whenever you look at these problems, you have to first see, is there a GCF? And then you look at the number of terms. When there's only 2 terms, it's either GCF, but you already looked for the GCF, or it's perfect squares. And so the perfect squares, they have to have a subtraction sign and they have to be perfect squares. And so X squared is always a perfect square, but other perfect squares, if you flip this paper over, it tells you the first 15 perfect squares. So if you don't have them memorized, which they're not hard to memorize, but it's just squaring things, starting with 1. So 1 squared is 1. And then we got 2 squared is 4. And then 3 squared is 9. 4 squared is 16. And it goes all the way to 15. So this is a really nice guide. If there's a number that you're like, I wonder if that's a perfect square, you can look at this to help you. So for this one, is 81 a perfect square?
Yes.
Yes, because it's the same thing as what squared? 9. So if you can rewrite it as something squared minus something squared, so this is the same thing as x squared minus 9 squared, then you're going to set up parentheses, and it's the same pattern every single time. The only thing that I'm going to write down is the base, not the square part. So it's going to be an x and a 9. Exactly. One of them is plus, one of them is minus. It doesn't matter what order. So you can take those parentheses and you can switch the order and it's fine. It does not matter. It does not switch the order. Or sorry, it does not change your answer. This one, the order matters. So 49 is a perfect square. 49 is the same thing as what squared? 7 squared. So in your parentheses, you're not going to have the x first. You're going to have the 7. So just be careful. It's the same steps. It's just you have the 7 first. For this last one, is 18 a perfect square? No. 18 is nothing squared. So for this particular problem, you have to first factor out a 2 because there's a GCF of 2. So if you first factor out a 2, so always check to see if there's a GCF. We put the 2 out in front. 2 divided by 2 is 1, so we just have an x squared. What's 18 divided by 2? 9. Is 9 a perfect square? Yes. It's the same thing as what squared? Yep. So we have x squared minus 3 squared. So this second part, these parentheses now can be factored. So the only 2 numbers I put in there, and they have to be in this order, there's going to be an x and a 3 in that specific order. And then it doesn't matter which one you make negative and positive, just one will be negative, one will be positive. So that is a difference of perfect squares. And if you just read the directions for each section, because 9 is the same thing as 3 squared, to be able to put them in this form right here, it has to first be written as something squared minus something squared. So we had to rewrite 81 to be 9. We have to rewrite 9 to be 3 squared. And so there was another one on your homework, and I think it was 121, or maybe it was on the notes, 121, and that could be rewritten as 11 squared. So as long as you can rewrite it, Erin, will you open the door? Hello. Oh, you're so nice. Somebody forgot their lunch. Oh, somebody just called, but he's not here yet.
He's not here yet? Okay.
He usually shows up every day, but I haven't seen him yet.
If you see him, do you want to just?
Sure.
Right. Okay. Thank you.
Uh-huh. Moving on, this one is factor by grouping. And again, there is a section on your notes that says factor by grouping. Anytime you see 4 terms, unless it's like the first one that I gave you and I told you just factor out a GCF, 4 terms is a good indication that it is factor by grouping. And so factor by grouping, and you learned this while I was gone, but I'm going to review it with you. Factor by grouping means that you're going to make 2 groups. So I'm going to make 2 groups. I'll have this first group and then this second group. Factor by grouping, the goal is to end up with 2 parentheses that are identical. If you don't, you did something wrong. So our goal is to end up with 2 parentheses that are identical. And what we're going to do in each one of these groups is we're just going to factor out a GCF. Factor out a GCF. Sometimes the only GCF is 1. If there's nothing in common, it's a 1. That's okay. But in this case, we do have a GCF for both of them. For this one, I have a 1 and a 9. Well, there's nothing in common there but a 1. but they do both have an X. So I can pull out an X from both of these. So I'm going to factor out an X for both of these. And when I factor out that X, it has to get written out in front. X squared over X. It just reduces to X. And then for the second one, the X's match up. So I'm left with just +9. My goal is that my parentheses are going to be the same. So if my first parenthesis has X +9 in it, the second one should too. If it doesn't, I probably did something wrong. Now, it doesn't mean that you did the first one right every time, but they should match. Oh, also, we forgot to check our signs. For this one, in my first group, my first term's positive, and then it's positive. For my second group, I have positive and positive. As long as the sign pattern matches, then you don't have to worry about ever factoring out a negative. But sometimes it's like you have positive, negative, and then negative, positive, so they don't match, and you have to factor out a negative. This case, it's good. We keep moving. For my second group, they don't both have an X, so I can't pull out an X, but I can pull something out. What can I pull out? 2. So I can pull a 2 out of both of them. Is that a positive or negative 2? Positive. So for your second grouping, you always have to say what the sign is. So for this one, since it's a positive 2, I put +2. 2 over 2 is 1, so I'm left with just an X. 18 divided by 2. Did I end up with 2 parentheses that are identical? Yay, that's my goal. I have to. If I didn't, I did something wrong. So as soon as I end up with those 2 parentheses that are identical, that's a new GCF. So I'm going to take that, because it's the same in both terms, and I'm going to factor it out, write it one time in the front. So I'm going to take this, and I'm going to write it one time in front. Now I write down what's left. What's left is the things in front of the parentheses. So I have an X and then a +2. That's going to make my second set. Again, you are not wrong if you put these in, if you happen to write down X +2 first and then the X +9, that's not wrong if you write these in the opposite order. They just need to, you need to have one parentheses that has X +9 and one that has X +2. And that's it. That is factor by grouping. The next problem is factoring a trinomial and the leading coefficient is equal to 1. On your handy dandy notes sheet, this could be helpful if you need some more examples. The top has factor by grouping when it's equal to 1. And then the bottom has factor, or the middle has factor by grouping when it's not equal to 1. So what we're going to do here is you will always get a list of factors for the last term. So I'm going to write a factor list for 48. I always start with 1. So we've got 1 and 48. 2 and what? 24. Is 3 going to 48? I don't think so. Yes. 3 does? 6. Okay. What about 4? 4 and Do y'all want to know a trick on how to find factors? It's in the calculator. What'd she tell you?
Go to y
And you divide it by X?
Yeah.
Yeah, so that's a great way to find factors. Use a calculator. You'll have a calculator. Why not? Do it. Let's see. Do we have a factor pair that will be able to put together to make 16? Negative 16. So the way that I do it, and some people do it different, that's okay. I always get my factors together. It will be X and X, and you just put them in there like that. You don't have to worry about the signs yet. You just put them in there. One will be 4, one will be 12. Okay, give me a second. We'll look at it. So to figure out what the signs are going to be, that middle term, yes. That middle term always tells you the sign of the bigger number. So that the bigger number has to be a negative. So which number is bigger, 4 or 12? 12. So the bigger number has to be 12. Or sorry, it has to be negative. So if I have negative 12, would I add or subtract to make negative 16? Subtract. So this one will also be a negative. On your notes chart that I gave you, or the notes page, on the back, on the bottom left, it actually has a little chart on here and it tells you, hey, listen, if that middle term is negative, then you're going to end up with both of the terms in the parentheses will be negative. But if you struggle with memorizing stuff like this, that's okay. You can always do that right there. If you know that the middle term is always going to be the sign of the bigger number, and then figure out what the next one is. And that's it. That's your answer. For question 12, for question 10, 11, 12, and 13, it says, use the graph to solve the quadratic. What is the solution of a quadratic? X-intercept. That's all it is. That's all it is. So from the graph, where does that cross the x-axis? Never. It doesn't. So there's no x-intercepts. So if you have something that doesn't cross the x-axis, all you got to do is draw your graph either happy and above the x-axis or sad and below the x-axis. The next question, question number 14. For these, if you have factored form, it is really simple to find your solutions. All you have to do is set each factor equal to 0 and solve. That's what you should have learned last class. So to find the solution in factored form, so these are factors. I'm going to back up so that we know that these are also factors. You can always take factors and find solutions. So if I have factors, I'm going to set each factor equal to 0. So I'm going to break it up and I'm going to say 4x minus 3 equals 0. And then 3x plus 4 equals 0. Yeah, take a pass. So for the branch on the left, what would my first step be to solve this one? Yep, it's a two-step equation. These are nice. So what do I do first for this one? Add 3. What's my next step? Very good. Don't give me decimals. I want whole numbers. Oh, sorry, don't give me decimals. I want fractions. So my solution set, I've got 3/4. Let's find our other one. It's going to be the same 2 steps. I've got to subtract 4. Hello. Yes. Sure, no problem. Zen, you are leaving. And then my next step, it's the same 2-step equation. So anytime you have factors, you can easily find solutions. You might have a question on your quiz where I give you factors and I want the solution. Those are easy. You don't even have to factor it. Question 16. We have to factor, then find the solution. Whenever you see two terms, and I'm not telling you to GCF factor, two terms should be easy. Look for a perfect square. Is there a 25? Can we rewrite it as something squared? So this is the same thing as x squared minus 5 squared. And as long as you can rewrite it as something squared minus something squared, then factoring it is super simple. You put the two terms in that same order, x and 5, and one of them will be plus, one will be minus. The order doesn't matter. From here, you can set each one of those factors equal to 0 and solve. So once you have factors to make solutions, you have to set them both equal to 0. So I get x plus 5 equals 0, and then x minus 5 equals 0. To solve, these are simple, one step. What do I do? Yeah, so on this one, I'm going to subtract 5. On this one, I'm going to add 5. What? Yeah, you just get x equals. That's what you're looking for. So let me ask you this. Do you think you could have done this one in your head? Yeah. I don't care if you show me work for a problem like this. These are a little bit harder to do in your head. Questions like this, I want you to write those out. But if it's like this, you don't have to. You can go straight to the solution. So it looks like on question 15, you're going to have to write them both out. So this should help with going back and doing day 2 homework if you were struggling with it. More factor by grouping practice. So first thing that we're going to do is split it up into 2 groups. You got it? Okay. We're going to split this up into 2 groups. And so I'm going to look at my first group and my second group. So for my first group, what would the GCF be for this first group? What's my GCF for this first group? I have a 1 and a 9, nothing in common there, but they do both have an X, so I can pull out that X. And when you factor by grouping, you take that and you rewrite it in the front. I would like for you to show me what I'm writing. It depends on once we get our factors, what they look like. For this one, no. So what we're left with, x squared over x is just x. Those x's will match up, so I'm left with a plus 9. For this one, my goal is to have 2 factors that are the same. That means my second set of parentheses better be x plus 9, or I either messed up on the first one or the second one. My second GCF, what is it? 2. The only thing that is in common is a 2. Is that a positive or a negative? Positive, so I'm pulling out a plus 2, and then I write down what I have left. Anything over itself is a 1, so I have an x. 18 divided by 2 is 9. I ended up with 2 parentheses that are the same. And anytime I do that, I write it one time out in front, because that's technically another GCF that you write one time out in front. And then I write down what I have left. So what I have left is an x and a plus 2. For my solution, Sid was asking, do I have to show work? I have factors. To find solutions is easy. You have to show me work, or can you tell me what is the solution when you have a factor that's x plus 9? -9 and -2. You can show work if you want to, but you don't have to. The next problem that we're going to go over together, and this is the last one that we're going to do together, is question number 20. This is another practice problem where we're going to factor a trinomial. So this is 3 terms. We have 3 terms. We want to look at that last number. And we want to get a list of factors of that last number. 36 has quite a bit of factors. I always start with 1. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Can y'all think of any others? (36) and 48 have a lot of factors. Yeah, factors of 36. Hmm? 3 works, yeah. So, which one of these factor pairs can we put together to make a 15? Or 3 and 12. So when I make my factors, and I haven't written any signs yet, so I put my factors. I have x and x, 3 and 12. I look at my bigger number. So my bigger number, is it 3 or is it 12? 12. So the bigger number has to be positive. So I put a positive right here. That's what tells me my bigger number. So if 12 is positive, if I have 12, but I need to make 15, am I going to add or subtract 3? Add. Here is also a hint. If what you're factoring doesn't have any negatives, your factors aren't going to have any negatives. So if you have 2 positives, you'll end up with 2 positives every time. Every time. So if I have factors, I forgot equals 0. If I have factors, can I easily write down solutions? Do I have to show work for these? No. What are my solutions? Not 3. What are my solutions? -3 and -12. So when you have factors and you go to solutions, it's just opposite. It's the same number, it's just opposite. And if there's a number in front of x, you've got to actually write that one out and divide. Give me fractions as answers. I will tell you that on the day 2 homework, there's like 7 total fractions in the answers. There's a lot of them. Give me reduced fractions, but don't give me decimals. Yep.
For 13, isn't on the